Welcome to another tutorial on MATLAB. In this tutorial series, we are looking into the concept related to the buck converter. In the previous tutorial, we have a look into the concept related to the boost converter. Along with that, we also had a look into the concepts related to proximity pilot, control pilot, and we also seen some part of the modeling in this particular tutorial series. So let's start with the buck converter. So to understand the problem related to the buck converter, we need to understand where it can be used, mostly a problem statement which we need to solve. So if you see, usually in an hybrid electric vehicles, you do find two types of batteries. One is the traction battery, another is a accessory battery. Basically, the job of accessory battery is to provide the auxiliary supplies like to the lights, to the fans, which is running in the hybrid electric vehicle. But the main battery is in this case is the traction battery, where we are considering in this case the 60 volt battery that we have is the traction battery, and the 12 volt battery that we have is the accessory battery. Now suppose due to some problem our 12 volt battery is not getting charged properly, and due to the same the SOC of the battery is gradually decreasing over time, and we also cannot directly plug in this 12 volt battery to the supply and do charge it. So this is our problem, and how can we solve this problem? So how we will prevent the 12 volt battery to drain out? So could be one possibility that you can charge the battery of 12 volt with the help of this 60 volt battery, which is the traction battery that you have. So to do the same, you will have to implement a buck converter. So using a buck converter, what you can do, you can convert this 60 volt to 12 volt. So to implement this, so let's try to see like how a buck converter is designed and how it is being used. What are the control parameters that we can use to control this buck converter? So we already seen that we have a solution, which is the buck converter. Now coming to the requirement that we want to develop. So here we have a 60 volt supply already with us, and we want to develop a output voltage of 12 volt. Definitely we will get some ripples, but which should be within an acceptable limit. So this is our requirement through which we will be developing our components, which are the inductors, capacitors, and the switching component. So coming to the buck converter design, we have multiple components. First is the DC power source. The second is the switches. Here we are using only one switch, which is basically controlling the connection between the source and the other components. There are two states for this particular switch. We will have an on state and another we will have an off state. We also use a diode, and we also use a inductor and the capacitor. So seeing the buck converter diagram, it is not enough. We need to understand why the converter is designed in this way, right? So let's try to analyze how the things happens on the left hand side after the switch. Okay, so coming to the switching part, if you see, we have a DC source. Suppose in this case, suppose you consider a 5 volt DC. Whenever you turn on the switch, then the switch will give a 5 volt output, and then whenever you are turning off the switch, you are getting 0 volt as the output. So in this scenario, what you are able to see, the fluctuation is happening between 5 volt to 0 volt. But if you find the average of the waveform, then you will find it at 2.5 volt. But the average that you are calculating is manually. It is not actually happening. So we need to achieve this particular thing with the help of some different components. So if you see a square wave, then a square wave will have multiple frequency components. Basically, these are called harmonics. And with the help of this, you can approximate by using multiple sinusoidal frequency wave to make this amplitude happen, which is basically a square wave. And you just can approximate it to the square wave because there are multiple frequency combinations that you need to adapt to build up the square wave. But in general, what we are able to see over here is square wave contains multiple frequency component inside it. If we try to block the high frequency component in this case, then we will be able to rise the voltage smoothly over time. And as you can see, the rise of voltage is slower with a low frequency component. And that way we can control something which will be more helpful to build up this buck converter. Now, coming to the right hand side part, we already have the square wave, then how we will be able to block the high frequency component. So to block the high frequency component, we need to design a low pass filter. As you can see over the picture over here, we have a square wave, and when we are getting a input on the left hand side, right, the input is changing from 0 to 1 in this case. And whenever this sudden change in the input is happening, the rise in the voltage is gradually happening, but it is also having some losses. So that's why it is not able to reach exactly the 1 volt. So same thing we can do, and with together both of the components happening together, the first part was the switching and the second part is the low pass filter. With that, we can achieve some smooth DC voltage on the output. So there could be two possibility in this scenario of the buck converter. One state could be switch on state, and in the switch on state, as you can see, the the capacitor is getting charged, and the inductor is also getting charged as the current is flowing from the source throughout the circuit and making these components charged. The inductor stores the energy in the form of the magnetic field, and the capacitor stores the energy in the form of electric field. So the waveform that you are able to see on the right hand side, the capacitor voltage will rise based on the current flow, and along with that, the rate of change of voltage introduce a rise in the inductor voltage. So basically you are rising the voltage, and if you apply the KVL in this scenario, so you will have some source voltage and there will be some voltage drop across the inductor, and you will be getting a voltage drop across the capacitor. So in this case, which you can see, inductor voltage drop and the capacitor voltage drop are summed up to the overall voltage source that it is getting provided. So in this case, which you can imply that the capacitor voltage is always less than the source voltage. So that is how you can prove that it works as a buck converter, because the input is higher compared to the output. The output over here is the capacitor voltage. So coming to the switch off state, in this case, we will be not getting connected with the source. The switch is off, and now the inductor tries to maintain the same current flow, because usually inductor do not allows the change in the direction of current. and because of that the current starts flowing in the same direction. But over here, as you can see, the capacitor voltage is gradually rising because there is still the current flow is happening. But now in this case the inductor voltage is decreasing because of the current that is flowing out of the inductor, because the inductor now is responsible for maintaining the voltage across the capacitor. Whenever there is this off state, the voltage across the inductor drops rapidly, and there is a good amount of current that flows inside the capacitor because of that. And in this case, the rise in the voltage happens quick in the capacitor, and you will get this uh, rise in the voltage in the capacitor side. So in conclusion, what we are getting now, so a buck converter is basically a combination of switching element plus a low pass filter. The switching elements will provide when to turn on and when to turn off the switch, but the low pass filter will tell like uh, how to smooth this components output, like the capacitor voltage output. So basically, if you try to observe like which are the parameters are responsible for which type of factor, over here you can see the turning on and off of the switches is controlled with the help of this BJT or IGBT or thyristor. But the smoothing of the waveform that we are getting on the outside or at the output is done with the help of this inductor and the capacitor. So this is the overall buck converter circuit diagram, and in summary what we seen over here is we have a switch which will control everything and will generate the square wave. So how the square wave basically gets generated? So usually we do not do switch on switch off manually for the switch that we have, which is basically an IGBT or a thyristor or a BJT, but we do it electronically. So how it is being done, you can see in the figure over here. So there will be a carrier wave, which is a sawtooth carrier wave, type of triangular wave. And you can see the carrier wave, it is crossing with the um, control voltage wave. So basically the control voltage is a control signal that we are passing through. And whenever you see the blue line is smaller than the yellow line, then at that moment the logic is true and it is turning on the switch and we are getting a 5 volt output. Whenever the reverse happen, we are seeing that switch is off and we are getting 0 volt as the output. So suppose you want to frequently control the switch, then you need to also change the frequency in this case. So the more frequency you give, you will get more frequent switching. But how long you need to turn on and off the switch, that you can decide with the help of this control voltage. So with the help of this control voltage, you can change the duty cycle of your wave, and that is how you can also implement some feedback control to maintain a defined voltage on the output side. So this is all about the buck converter which we seen. In case you are liking the channel, please consider subscribing. In case you have any comment or query, please let us know in the comment section. We will be more than happy to clarify your doubts and query. Have a great day ahead and happy learning MATLAB. Thank you.